they gave you a picture here to look at. When satellites observe the Earth, they can scan only part of the Earth's surface at a time. And then the satellites have sensors that can measure an angle shown in the figure. So they give you all this picture, and you have to figure out how to set this one up. But you guys have all learned in the past about like sine, cosine, and tangent and triangles. So you should be able to look at that and see it's a right triangle and try to figure out if you'd use like sine or cosine or tangent to set it up. What do you guys think? They gave you an angle here, and then this side way over there is across from that angle. And then this side, what's this side called? Hypotenuse, yeah. So what kind of setup would you do for number 90? Would you use sine or cosine or tangent? Yeah, sine, because you have opposite and hypotenuse. So it is kind of weird because you have letter R's and H's and stuff, but you can do it. You can set it up. It's like sine of that angle, theta. Sine of theta equals opposite set R. And then the hypotenuse had those two letters on it. Oh yeah, sorry. So sine theta equals opposite over hypotenuse. Well, the hypotenuse said R and H on it, so you have to put R plus H. See, because it's like the whole side there of the hypotenuse. R plus H. And then you have to kind of mess with this equation and manipulate it, and you have to solve this for H. Because it said show that this is the same as H equals R cosecant minus 1. So you have to mess with this and manipulate it. So I would try to get rid of this fraction, like times by R plus H on both sides. You know, if you do that first, then it'll cancel the fraction on the one side. So then you have R plus H times sine theta equals R. So then you don't have a fraction anymore. And you're trying to solve for H. So this R plus H is kind of like a group right now. So now I would divide by sine theta. And this isn't the only way to do it, but because like yesterday a student asked, well, could we distribute that? I'm like, yeah, you could, but you still have to keep working on it until you get H by itself. So then if you divide by sine, you get R plus H equals R divided by sine. And then it said solve for H, so I'm almost done. Then I have to minus R. Then I'll have it. Then I have H equals R over sine minus R. And then I think then they just factored out an R, because you can see they both, there's a couple R's in there. So then it's 1 over sine minus 1. See, it's just manipulating it. And 1 over sine is the cosecant. So then that part A is done. Then you've worked on it until you got H by itself, and you got R times cosecant minus 1. Then they told you that R is the radius of the Earth, and they said for R, use the number 4,000 in the story problem. So you could put in the 4,000 for R, because that's just a constant. So now we have like a formula like that. You can plug in the 4,000 because it says find the rate at which H is changing with respect to theta. And then in parentheses they said assume that R is 4,000 miles. Okay, so now we're going to find the rate at which H is changing. The rate at which H is changing would be that derivative, like the change in H. Like how is H changing? So you just have to find the derivative of this. Then we can plug in the angle that they gave you. And since 4,000 is just a constant, you can leave the constant in front, and you just have to, it's just the constant times the derivative of this. It's like first times the derivative of the second. Like you don't have to do anything with the 4,000. So you just have to figure out the derivative of cosecant. So do you remember what derivative of cosecant was? It should be negative something. Yeah, it's cosecant cotangent. And the derivative of 1 is 0. So we get this. Now we can solve it. Then they want you to plug in the angle. They tell you to do 30 degrees. So you have negative cosecant of 30 degrees, and then cotangent of 30 degrees. And if you want to, you could write cosecant you could write these back as sines and cosines so you can figure them out and just do it. So cosecant was like 1 over sine. So it's like 1 over sine of 30, negative 1 over sine of 30. Cotangent is cosine over sine. So it's like cosine 30 over sine 30. So it takes a little bit of like working this out. I like to not always rely on my calculator. I like to review those like 30, 60, 90 triangles and stuff too. Remember 30, 60, 90 triangle? You can figure these out by drawing a 30, 60, 90 triangle. Across from the 30 is the side that's 1. Hypotenuse is 2. Across from 60 is square root of 3. So you can label it, and now you should be able to figure out like sine of 30. Sine of 30 is 1/2. You guys might have that memorized from the unit circle. I always do them like with the triangles. I never learned unit circle ever. Like I always learned it off triangles. That's how I learned it. So it's fine. It's just how people learn things. My teacher taught us to always draw the triangles. So sine of 30 is 1/2. And then cosine of 30 is square root of 3 over 2. Because it's just adjacent over hypotenuse. And then sine of 30 is 1/2. So it's like, yeah, it's kind of messy with all these fractions, but you can figure it out. Let's see. This is negative 1 over 1/2. That's the same as like negative 2. If you take square root of 3 over 2 and divide it by 1/2, that's the same as square root of 3. So it's just like 2 square root of 3. So it's 4,000 times negative 2 radical 3. And then that's basically the answer. The answer the book has, then they times the 2 and the 4,000, so they got negative 8,000 square root of 3. So if you do it by hand, then you have it in the simplest radical form. If you draw your triangle out, that's how the answer the book has. The rate of change is negative 8,000 radical 3. Yeah, so that one was a tough one, that number 90. Is there any other ones you want to go over? 86, yeah, that one's another one they give you a big formula to work on that one too. Okay, 86. Let's see, I had that one here. All right, so they gave you a formula that had 500, 1 plus 4t over what, 50 plus t squared, I think. If I write it down right. Okay, so this one, let's see what it was about. Population growth. A population of 5,000 bacteria is introduced into a culture and grows according to this equation. T is measured in hours. Find the rate at which the population is growing when t equals 2. So when they say find the rate, like a rate at which the population is growing or changing, yeah, you have to find the derivative. Yeah, so it's like find the derivative and then plug in t is 2. So you can't just plug in 2 into that equation. You have to find the derivative first because they want a rate of change of this population. So we'll have to find the derivative of this. The constant in front, the 500, you can just leave that there. You can just leave the 500 there. Because earlier in the chapter they said if you have a constant times some kind of function, you can just do constant times the derivative of this function. So you can just leave the 500, and then you just have to find the derivative of this. It is really the same as like product rule, like first times the derivative of this, and then plus this times the derivative of that is 0, so that's why you don't have like the second part. It's just like first times derivative second, that's it. So 500 times the derivative of this. Well, what's the derivative of 1? 0, okay, so So I have to just figure out the derivative of this fraction thing. You're going to have to use that quotient rule, that low d high minus high d low. Low times the derivative of the high part is 4. So this times 4. Oops, I don't want to make a little 4. I almost made it like 4th power. This times 4, there we go, minus the top part, which says 4t, times the derivative of the bottom. The derivative of the bottom is 2t over the denominator squared. There, so it's like that. On the top, you could distribute this 4, and you could times these together. So we got 500 hanging out here. Okay, so 50 times 4, that'd be 200 plus 4t squared minus 8t squared over 50 plus t squared quantity squared. So I would just combine like these right here, the 4t squared minus 8t squared, and then just leave it like that and plug in the number they said. So then it's not too bad. So you got 200 plus, or it's actually minus 4t squared. 200 minus 4t squared over this denominator squared. Now you could just plug in the number 2 into that and work it out, and you should get the answer. Yeah, so it's a little messy, but you guys can do it. So now it's just plug in the number 2 into this derivative. So you can find the rate of change of this population. So yeah, on the top you have like 200 minus 4 times 2 squared. Oops, I gotta get this turned on. Okay, 200 minus 4 times 2 squared. So this top part I have like 500 on the outside still. So on the top I got like 184 over, and then I can work out the bottom part. Let's see, 2 squared is 4. 54 squared is 2916, if I did it right. And then if I just finish that up, you should get the answer. 500 times 184 over 2916. Put it as a decimal. Maybe fractions to decimals. There it is. Yeah, I got 31.55. And that's the rate of change, like how much the population of this bacteria is growing. Bacteria per hour. Yeah. Yeah, they take a little bit, these story problem ones.